Hello, this is Mr. Collier, and today we're doing combinations. Okay, so let's look at the definition of a combination. The number of ways of selecting R objects from N objects where the order does not matter is called a combination. So that's how it's different from a permutation. In a permutation, the order does matter, but we're going to derive the formula for combinations from the formula for permutation. So let's take a look at the number of permutations for selecting three letters from this group. So the number of permutations is, well, there's 5 ways to choose the first one, 4 to choose the second one, 3 to choose the last one, which is 60. And remember, that's equal to 5 factorial over 2 factorial, so remember that fact. Now let's look at part 2 here. So some of these permutations share the same letters. So for example, if you pick A, B, C, B, that's the same letters but in a different order. So as far as combinations are concerned, that's the same combination. Okay, so if you had BAC and BCA, those are the same combination of letters. And you can start with C, you have CAB and CBA. So there's six overlaps, which equals 3 factorial. So these 6 are overlaps, so we don't care, but they're actually 1 instead of 6. They're 1 combination, but 6 permutations. And that happens for each of the combinations in this list, right? So to get the number of combinations, that's going to be simply 6 divided by 6, which equals 10. Okay, and if we look at it in terms of factorial, it's going to be 5 factorial over 2 factorial, 3 factorial. So we're basically dividing by 3 factorial. Okay, so that is where the formula comes from. We say the number of ways to choose, the number of combinations from n objects, so the number of combinations of r objects from a list of n is equal to n factorial over r factorial n minus r factorial. Okay, and now this is also written as often like this. This is the notation I'm going to be using in this vector notation. This means n choose r. Okay, the number of ways to choose r objects from n possibilities. So that's where the formula comes from. Let's look at an example. We can think of combinations as how many ways there are of choosing r objects from n. Okay, how many ways are there of choosing a team of 11 from a squad of 15? There's no restrictions. So that's just 15, choose 11. Then you can use the formula, and you can work it out by hand. I'll show you how to do it on the calculator in a second. It's just 15 times 14, blah, blah, blah. 11 is very similar. Then we got 4 factorial is 4 times 3 times 2 times 1. But this will cancel out with 11 on the top, so you just be left with 13 and 12. 3 times 4 is 12, so we can cancel those out. We can divide by 2, so the answer is just 15 times 7 times 13. Okay, you always get the denominator to totally cancel out. Anyway, let me show you on the calculator, on this particular calculator, the HP Prime, how to do that. We can go to this toolbox, just a second. Toolbox, probability, we got permutations, combinations, factorial, all there. So you do combination and you do 15, comma, 11, and it gives you the answer 1,365. Okay, that's the same as 15 times 7 times 13. Gives you the same thing, so that's 1365. Okay, let's look at the next one. How many ways are there if the captain must be selected? There's one captain on a team, and he has to be on the team. He has to be playing that day, I guess. And there's 2 goalkeepers. I'm going to pick one of those, just one of those, and then we pick the rest of the team. So the captain must be chosen. There's one way to do that. There's one choose one way, which equals one way of choosing the captain. And we're choosing from 2 goalkeepers. So let's choose one, which equals 2, right? That's common sense. There's 2 ways to choose the one of the two goalkeepers. And lastly, we got how many people on the team? There's a team of 11. So we got 12 left over. We got 12 people that are not goalkeepers or the captain. So we got 12 choose 9 here. There's 9 more members of the team. Okay, so that's going to be actually 220 if you type that into your calculator. So the total number of ways is 440. Okay, let's look at another example. There are 4 places available in a company. There are 6 women and 5 men applying. How many ways can the places be filled if there cannot be all men and all women? So the easiest thing to do in this kind of question is do the total minus all men minus all women. That'll give you all the possibilities without all men, all women. So the total is, well, there's 11 in total, 11 people, and we're choosing 4. That's the total number of ways to choose committees of 4. Number of ways to choose it with all men is to take do 5 choose 4 because there's 5 men and you're picking 4 of them, and all women is 6 choose 4. So if you type all that into your calculator, you get 310 ways. Okay, in the next example, we got a committee of 6 is to be selected from 4 men and 5 women. Given it must contain 3 men and 3 women. How many ways can be formed? Well, there's 4 men, and we want to choose 3 of them, so that's going to be 4 choose 3 ways to choose the men, 5 choose 3 ways to choose the women, and you just multiply these two together, and you get 40. Next, how many ways are there if Mr. and Mrs. Smith cannot serve on the same committee together? So again, that's probably easier to do it 40 minus number of ways they are together. Which is, to work out how many ways they are together, well, you're selecting 3 men for the committee. One of them is already Mr. Smith, so then you have 3 choose 2 ways to choose 2 men from the 3 remaining men. Okay, and then for the women, you're choosing 2 extra women from 4, because there's 4 women who are not Mrs. Smith. So if you work that out, we get just 22 ways. Okay, let's look at this last example. A committee of 4 is randomly chosen from 7 girls and 5 boys. What's the probability that the committee contains exactly 3 girls? So if it contains exactly 3 girls, that means we choose 3 girls from a group of 7. And then we choose 1 boy from a group of 5. And it's a probability question, so the denominator is the total number of ways, which is 12 choose 4. So that gives you 35 times 5 over 4 is 95. Or you can just type this exactly into your calculator and get the answer. This is the answer as a fraction, which is about 35.4%.